Yes, welcome back to the session. In this video, I'm going to discuss about ballistic pendulum. Okay, so look at the diagram here. So this is the wooden block of mass is capital M, which is connected with the help of two strings. So this is the massless string. Okay, so initially this wooden block of mass capital M, which is at rest state. Okay, so look at here, this is the bullet of mass is small m, which is moving with initial velocity u, and when it hits the wooden block like this direction. Okay, so whenever a bullet enters into the block, then what will happen? Momentum is conserved, right? So I'm using here from law of conservation of linear momentum. So law of conservation of linear momentum. So what is law of conservation of linear momentum formula? We have two objects, right? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the basic formula of law of conservation of linear momentum. Okay, so here mass of the bullet is small m, right? So instead of m1 I'm taking small m, and velocity of the bullet is u, so mu plus m2 means mass of the wooden block, that is capital M, into initially the wooden block is at rest state, so u2 value is 0, is equal to when the bullet it hits the wooden block, finally this bullet penetrates into the block, so the total mass becomes wooden block mass plus bullet mass, this both moving with common velocity v. Okay, so v is nothing but common velocity. Okay, so let's see the next step. This mu as it is I am writing is equal to capital M plus small m into v. So bring this v left side, v is equal to mu by capital M plus small m. Okay, let us assume this is equation number 1. Okay, so look at the diagram carefully. Initially the block is at rest state, right? So at this location the wooden block is at rest state. Whenever a bullet hits the wooden block like this, bullet enters into the block, so therefore the block acquires kinetic energy, correct or not? So due to that kinetic energy, this block moves up to here and it makes an angle theta with respect to the actual line. Okay, so here both wooden block and bullet having kinetic energy, right? So whenever the block is moving from original position to some height like this direction, the kinetic energy is converted into potential energy, because whenever a wooden block is moving in this direction, it raises to a height h. So whenever height is present, potential energy developed, right? So here kinetic energy is converted into potential energy. That means kinetic energy losing, that is potential energy is gaining, right? So I'm going to write here, due to the movement of the wooden block from one place to another place like this direction, kinetic energy at lowest point, I'm writing here kinetic energy at lowest point must be equal to potential energy at height. Okay, so kinetic energy basic formula is half mv square. So whenever a bullet enters into the block, so the total mass becomes capital M plus small m. So kinetic energy at lowest point is, we can write it as half into capital M plus small m into v square is equal to potential energy due to this height is capital M plus small m into gh. Okay, so left side capital M plus small m cut, right side capital M plus small m cut. The rest of the equation is V square by 2 is equal to GH. Just a second, I will go for next slide. Look at this last equation. Okay. So finally we got V square by 2 is equal to GH, right? So from this, V square is equal to 2GH. So take this square right side, it becomes root. So V is equal to under root 2GH. Okay. So after getting this equation, look at the diagram carefully. Before hitting the bullet having kinetic energy, that is half mu square. Okay, so whenever a bullet enters into the block, it loses some kinetic energy, correct or not? So next we are going to calculate change in kinetic energy. So next I'm going to calculate loss in kinetic energy. That means initial kinetic energy minus final kinetic energy. Okay, so therefore loss in kinetic energy means we can write it as delta Ke is equal to initial kinetic energy of the bullet is how much? Half mu square. Half mu square minus final kinetic energy means how to write? When a bullet enters into the block, the total mass becomes capital M plus small m. So we can write it as half into capital M plus small m into V square. Okay, so after getting this step, look at here also half present, here also half present. Take common term outside. Therefore, half into mu square minus capital M plus small m into V square. So this is the change in kinetic energy or loss in kinetic energy. Let us assume this is equation number 2. Look at this equation 2 carefully. We have V square term here, but V formula we know. So what is the V formula? Small mu by m plus m, right? So I'm going to substitute here. Let's see the next step. Half mu square minus capital M plus small m into V value is small mu by m plus m. Small mu by m plus m whole square, because V square will be there, right? Now what I'm doing here, I'm writing next step half into mu square minus capital M plus small m. So m into square means m square, u into square means u square divided by capital M plus small m whole square. Okay, this is the expression I got. So finally, look at this expression here. Numerator here m plus small m will be there, and in denominator m plus small m one time cut. The rest of the equation we can write it as half into mu square minus m square u square by m plus m. Okay, so this denominator m plus m is multiplied with this term. Let's see the next step. We can write it as half capital M into small m into u square. So plus will be there, plus small m into small m square u square minus this term m square u square divided by denominator term is capital M plus small m. Okay, so in this expression here small m square u square minus small m square u square cut. The rest of the equation is half into capital M small m u square by capital M plus small m, or we can write it as half into capital M small m by capital M plus small m into u square. Okay, so this is the loss in kinetic energy. of the ballistic pendulum. I hope you understand. Thank you so much.